Let me take a look at number 81H here and see how we set this integral up that gives us the volume of the solid form by rotating this region. This is the region that's given, and I've redone it on a graph here. It looks a little bit different if you look there because my I've got it a little bit more spread out horizontally. So, but this is still the same curves we had. It's bounded. It's in the first quadrant, bounded by the line y equals 6 minus x. Of course, that's a line of slope -1, y-intercept 6. So you go, you go down 1 and over 1. Notice 1 in this direction I've got is 2 units. So it goes over 1 this way, then down 1 and over 1, so on. So that's that line. And then this is the graph of y equals x squared. You can see 0 squared is 0, 1 squared is 1. That's the height of 1. 2 squared is 4. So it's that parabola if we were to graph that parabola, right? But again, we're just looking at the region bounded by those two curves in the first quadrant. And then we're going to take this region, we're going to rotate it about the vertical line x equal 5. Remember, x equal 5 is a vertical line. X is 5 on this line. Y can be anything, so it's a vertical line. And so we're going to take this region, it's going to rotate all the way up and go back into the page over here, and we're going to get this solid. Now to find the volume, we're going to look at just this little rectangle here, and I'm going to move it out here to an arbitrary value x, so that the distance from the origin or from the y-axis is x units, right? And I'm going to rotate that about x equal 5, and it's going to go around and form this thin cylindrical shell. And I've, for sake of space, I've contracted it down, back down. So here's x equal 5. So that would be our axis of rotation, right through the center of this, right? And right here, this is our rectangle. It's going around, right, forming this shell, thin cylindrical shell. There's that rectangle. And the two dimensions we need, if you remember from the lecture video, we need the radius of this thin cylindrical shell, and then we need the height, right? And then the volume is going to be formed by, this cross-sectional area. If I were to cut up the side and unroll it, I'd have a rectangle. The height is h, and the width would be the distance around the circle, which is 2 pi times the radius. I'm calling the radius p. And so you get 2 pi p times h. That's what we're going to integrate, right? Of course, we're integrating from x equals 0 to what? X equal 2. That's the point of intersection here, right, of these two curves. So that's where this region lies, from 0 to 2. Okay, so what is this radius? Well, the radius will be from our rectangle to our axis of rotation, right? This length right here. So here's x equal 5. This is what? X, right? So if this distance is x, then from here to here must be what? 5 minus x, right? So from here to here is 5 minus x. From here to here is x. Total distance is 5. Okay, and so that's 5 minus x. Okay, and that radius makes sense if you think about it. You can see as our rectangles move, right, get closer and closer to, as x gets closer and closer to 2, the rectangles are getting smaller and smaller and smaller in height, but that radius is approaching 2, right? In fact, approaching 3, excuse me, right? 3 units. From 2 to 5 is 3 units. And when x is 2, I get 5 minus 2, I get 3 units right there. Okay. So that's the radius. The height, of course, is just going to be what? The sort of the top function, which is 6 minus x, minus the bottom function, right? X squared. So 6 minus x squared, there's the height. All right. So those are the pieces of the puzzle that we need. As we said, the area that we're going to integrate is 2 pi p times h. So p was 5 minus x that we found right here. H, the height, was 6 minus x squared. And we're integrating, notice, from 0 to 2, right? That's where the region is. We don't go from 0 to 5, right? It's just where the region is, right? We're finding, it's almost like if you were finding the area of this region, you'd only be integrating from 0 to 2, right? So I hope this clarifies how we set this up. In this problem, you're not asked to evaluate these integrals, so don't take the time to do that. I mean, if you want to use your calculator to approximate it, that's fine. As a check, that would be a good idea. You're getting volume, so you would expect to get a positive value here. So hopefully this helps in setting this one up.